After Neil's speech at SETP, I had lunch with him and presented my proposal for a conference to share the Apollo lunar landing research and training experiences with the LLRV and LLTV. I had already received commitments from ASU and the U of A to sponsor the conference. Neil thought it was a good idea, so this is the cover of the conference report. You can download it at lunarlanding.info. The conference was well attended and motivated. The NASA JSC Altair Project Office to sponsor a trade study by NASA DFRC on potential future lunar landing training options for a free flight trainer. I authored this white paper in September 2008. It will be available on lunarlanding.info and alitro.org for download. On December 9th, 2008, NASA JSC Altair Project Office hosted a one-day conference for the Apollo team to share their experiences for training for lunar landings. Here are 4 clips taken from that conference from a 3 DVD set I produced this year. You can see the attendees on the Apollo team. We had 4 moonwalkers there and myself, the NASA Johnson Space Center team, and then the NASA Dryden Flight Research Center team. Here's the first movie clip.
Anything else? Anything else? Do you put any wrap-up comments?
Nothing more than just expressing my great gratitude for you guys taking the time. I mean, this is exactly what we wanted to try and get out of the meeting, and likewise to you guys sitting here. It's helped immensely. I think John hits our expectation and exceeds it. So this is valuable information for us for the future, and I think we got the message. I think most of us sitting here agree with the, I don't know about the kite and the string, but absolutely the with the fact that we need something, and so what we get to have fun doing is figuring out what the something is.
Hey, in reverse, it's nice to know that you're still loved and wanted.
I don't know about the love.
You know,
obvious to me.
And we're gonna. It won't be long, and there's gonna be fewer of us here. You know, and if you waited another 5 years, you may not have as many of us to talk to. Another 10 years, probably less than that. And God knows, in 20 years, we'll be looking down from somewhere. I suppose watching what you do. And
Looking at me down.
Yeah, but you'll be blabbering and slobbing and all that stuff. Seriously, to be able at least to give you our opinion, do with it what you want. Do it. We don't, you know, other than a strong support for what you're doing. I personally don't have a dog in this fight, and I just want to see you be successful. And if what we say taints or your opinion one way or the other, use it in a manner in which you want. Like I say, from a technological point of view and from a capability that you've surrounded yourself with these kind of people, you're a winner. You can't lose. And don't think we're absolutely right. Just say,
Yeah.
you know, on the other hand, you gotta, this is not a history of simulation. This is a history of 6 successful lunar landings. And so someone's got to say, hey, they did something right.
Right. Well, I mean, you gave us a tremendous gift in making our job easier by having done it all those years ago. And you continue to give by your willingness to interact with us as we try to redo it in this day and age, and solve the same problems with new technologies in a different time. So we're really grateful to you for taking the time to come here. And I would go so far as say loved. I would go so but I'm a woman, so I can.
I tell you what, if you're here in 10 years, I'll be here in 10 years.
Okay.
Because you were first on the moon. All I did was follow in your footsteps, so that's the way it's going to be from here on out.
I hope Gene is absolutely right about the timing and how long they're going to be around, but I just want to share with you that out of a number of key people, we're losing them at 3 or 4 a year on this program, either Alzheimer's or death, and it's the sense of urgency on me is it's very urgent to capture and get all this feedback as early Myself and Dave Scott, the Apollo 15 commander, have comments at the end of each clip. Here they are. A second movie clip.
Going in today is whether you need to fill the gap between a simulator and the real world. I hope you got the message that it's yes, which is shorter with John's feeling. John doesn't feel it, but that's his opinion. And John's sure flown a lot of spacewalks, including the STA and everything else. But would John have liked to fly on a shuttle without the STA?
Yeah, I said no.
Would the shuttle simulator been enough for you guys to go and fly? Well, there's your answer.
I think his bias on the LLTV, from what I understood, was a safety one. You know,
Yeah.
he didn't accept the assertion that you could make it safer than the one that you guys flew. So given that assumption, he said, for what I get out of it, the risk for me, I wouldn't take that trade. I wouldn't recommend going
You
there.
think of the time frame this was happening, this, in the 60s, we were dropping airplanes left and right. And I mean, new aircraft designs, pushing the edge of the envelope on stuff. They didn't have all the...
In the time that
simulation.
we had our 3 crashes, they had several fatalities in the T-38s and lost some helicopters.
Well, I mean, you two are the guys that might someday get the call to actually go, sit across the table. What are your thoughts? Probably too low.
You're right.
So Mac, if you're going, what do you want?
I think once we know the task well enough, I think we need to pursue a flying vehicle, and the LLTV seems to me to be the best option. And I think we can do it better today, but I want to understand the task better because.
Comments for the preceding clip. Our August 2008 conference at JSC on the trade study received input from the crew or astronaut office that modeled the future trainer much after the shuttle training aircraft or STA. The astronaut representative had been an STA instructor pilot for 20 years and did not appreciate the fine points as shown here by Dave Scott as to how unique the lunar landing training should be viewed. Dave has some 14 pages of comments indexed to the movie clip comments as shown here by note P. I hope to have those on the lunarlanding.info and alitro.org websites as well soon. Dave Scott's comments continued, and these are available on the Acrobat 9 disc. That's the middle disc number 2 in the 3 DVD set that Dr. Whitmore has a set of. The final page of Dave's STA comments for this clip. As you can see, it goes into quite a bit of detail. And the third movie clip.
Al, did you want to say something?
I just want to follow up on something you were hitting on a minute ago. Originally it was like a discriminator between whether or not you needed an LLTV, but it seems to be more a discriminator between this gimbal jet concept and the other 2 helo concepts, and between the gimbal jet concept and the STA. It's this idea of the reset button and the fact that this gimbal jet concept, like the LLTV, doesn't have it, but all the other ones appear to have it. How important is that really?
Well, I use the reset button as just an example. You're in a simulator, and you screw up, and we screwed up, and blew up, and landed hard, and screwed up malfunctions, and one thing or another, and that's what simulators for. And you do it again, and you just stop. Let's go out, have a cup of coffee, and talk to the instructor. Where did I screw up? How could I have done it better? What did I miss? What did we miss? We're a team in there. And so then when I talk about the reset button, that's what I refer to. But I'll go back to something. What is it? Scorch. What you said earlier. You go out in the STA. You're planning to shoot 10 landings, right? You said a minute ago, which one's the most important that you prepare for, that you're most focused on? It's the first one. That's your first shot. And that's what I'm trying to say. You don't have a reset button in an LLTV. You don't have a reset button in a lunar lander, that's the first landing, and it's got to be the one you focus on. And the fact that you don't have a guy who can, a safety pilot to save your butt, the fact that you can't say, stop the world, I want to talk about this thing I just messed up on. You don't have that. You've got
3 minutes
got-
remaining. This conference is showing no activity. If you would like to continue the conference, please
Activity. And, I mean, it's a philosophical thing, but you brought it home to me when you said, I'm going up to make 10 landings in the STA, but man, this is the one that's going to come. The first one. That's the one you got to make happen. And the LLTV puts you in that psychological environment. I'm up here. I got to make this landing. Ain't anybody else going to make it for me?
Would that be a discriminator?
And that's where you are when you're on the moon.
Would that then be a discriminator against the sky crane and then the other helicopter and then also the STA then? Because they do have the safety pilot.
I'm not against it. All I'm saying, if you want to throw a safety pilot into the system, throw him or her in. I'd be careful. I use the word him generically. If you want to put a safety pilot in the system, put it in. If you can afford it, it makes it less risky, that's fine. All I'm saying is you're giving up a valuable part of that simulation. And that's the psychological effect of taking you one step closer by yourself. You kind of, but without mission control, without by yourself, one step closer to the real world of landing on the moon. That's all I'm saying. That's me. Other people may disagree with that. You put a safety pilot in, fine. You lose a little, you reduce the risk, you gain safety, you spend more money, but you also lose what I think is a very valuable part of the LLT simulation. And that's having to do it.
And you could increase mission risk because you did it that way.
Pardon?
You could increase mission risk because you did it
That's
that
the
way.
point. I want to take the risk here.
Right.
Right.
I can get out of screwing up here. I can't get out of screwing up out there. It's
Okay.
One minor point. This throttleable, this gimbalable engine. That might have an effect on vehicle motions such a way that you want to somehow incorporate that in the simulation. I don't know if it will or not, but you need to know whether it will or not. So you might go on the track of finding out to what extent it might affect the simulation and how, so it could be implemented if it was
Yeah,
important to
yeah.
do so.
Yeah.
See, in all simulations, we can freeze time. You can't freeze time in the real world. And the LLT puts you in, quote, that real world. Is that valuable? I think it is. You all may have your own opinion on it.
There appears to be a discriminator between these three concepts. That's why I wanted to bring that up.
My name is Wayne Ottinger, and this is a collection of material that I've made quite a few slides of, and it's my collection pertaining to my 2 years spent 1960 to 62, 2.5 years as the X-15 propulsion engineer at NASA Flight Research Center in flight ops. And I have a couple of websites here at the bottom with my contact information, which I'll get to later on in the program. Just a couple of slides here on my short bio. I've shown here the pictures of the F-104, B-58, F-11, 1F, and the Regulus II missile. These were all projects I worked on as a first half of that 1956 to when I first arrived at Edwards to 1960 when I joined NASA with Jim Love. But those projects I worked on in that period, the first half was for General Electric flight test, and the second half was for Chance Vought. And a short assignment over in Phoenix with Rocket Power Talco on ejection seats. My additional experience in the 70s and 80s was organizing and running workshops for the California Energy Commission, providing technical films for the Navy on the surface effects ship program, and founded and managed 2 nonprofit corporations. And I was also in the, starting in 1963, January, I moved to Buffalo, worked for Bell Aerosystems in Niagara Falls as a project engineer on the Lunar Landing Research Vehicle, and then came back in April of 1964, and we flew the first flight of the LLRV in October 30th, 1964, 6 months after we got it delivered out of Bell in parts and pieces. The LLTV was a follow-on. I had joined Bell Aerosystems as the technical director on that program in June of 1966, just before Joe Walker was killed in that midair with a B-70. And back in 2007, Neil Armstrong asked me to help him with a SETP paper he was delivering at the end of September. So I went over and had lunch with him, and I had already gotten the U of A and Arizona State University to sponsor a conference. Neil thought it was a great idea, and we held it in March of 2008, and that resulted in NASA JSC initiating a trade study for NASA DFRC to perform, and then I've assisted them as a SAGES consultant, and also done consulting for Orbital Sciences in Chandler on a new generation LLRV and LLTV. The last December, I was able to get Neil Armstrong and Gene Cernan, Harrison Jack Schmidt, and John Young to come to Houston, and the 4 of them and myself briefed the Altair project. NASA DFRC had representatives there, and also other NASA centers had sent representatives, and we briefed them on our training experiences from the 1960s. And just a year ago, formed another new nonprofit to target collection of personal collections of important technical data that didn't make it into the government archives. So far, we've got about 25,000 pages of LLRV and LLTV documents, and recently got another collection out of Dean Grimm's basement out in Denver, and it's sitting up at the Colorado University in Boulder, and it spans all the way from Mercury to Skylab and the shuttle. And otherwise, it was headed for the shredder. I think it was 30 or 40 boxes of material. And now I'll start with my X-15 recollections. Joined in April of '60, and within a few weeks, we had a U-2 in the hangar, first time we'd ever seen it. And Joe Walker had to taxi it for the press, having never been in the cockpit before. It got an overnight paint job on the tail to put NASA on it. Eisenhower claimed it as a NASA experiment after Gary Powers was shot down over Russia. Norm Foster and I attended an AIAA meeting in Burbank a few years later, got to meet Francis Gary Powers before he was killed in his helicopter accident. One of my first tasks on the X-15 was to suit up with an inspector, get out on the XLR-11 test stand with the 4 chambers running, and with an inspector look closely at the welded check valves on the injectors to see if there were any LOX leaks. I figured Jim Love was testing me. I went to the XLR 99 school at RMD, Reaction Motors, in Danville, New Jersey for a whole month in June of '60. And I served as a non-drinking driver for Tom Raskowski and John Reeves as we visited every bar in a 30-mile radius after school every night. One of the early experiences with the LR-11 flights on the X-15, I can remember 3 flights in a row that we had one of the engines shut down. That would be 4 cylinders on one engine, always shutting down in a left-hand turn. And we finally had to ground the airplane and take the structure apart, find the wire bundle all the way back from the cockpit to the engine bay. And we finally had found a bare wire, 1 wire in hidden in the bundle next to a bulkhead, which was coming out and shorting where it was bare and causing the engine to shut down. I can remember a lot of delays for critical parts that we needed in the engine control box, such as improved pressure switches with gold plating. And they were giving us fits, and I would track down the vendors and get the skinning on delivery and then curse Bob Bradford and Billy Arnold over the UHF link. And I don't know if it was FRC to Beatty, but it was which end I was on, but they were on one end, I was on the other, for giving me the company or USAF line to me, and I got chewed out by my boss, Perry Rao, for using foul language on the radio on the UHF, said it was against the law. My hassling Arnold and Bradford and Jerry Brandt earned me the name of Murphy after Murphy's Law. Probably earned the nickname with a few boners I made as well, but can't remember what they were since I've made so many since then. My most proud accomplishment was the coating machine, which was named Murphy's machine at the time for the replacement of the fragile rockite coating. I should mention that RMD used the rod-fed rockite application method on the original build of the engines, and this was before the injector was ever welded onto the face because they couldn't get the rod-fed spray machine through the chamber to coat it with the injector welded on. So when we started losing rockite in the field, and we couldn't afford to have the ammonia leaks when the stainless steel tubing would crack for loss of the coating due to the heat, Bickle asked me and Al Covington to try and get a solution for it, and we started visiting labs around, came up with a plasma arc spray with gradated coatings that could improve the quality by putting pure metal on the surface and then gradually adding a few thousandths at a time the ceramics until you got out to a pure ceramic at the flame front. And the most significant part for this was that the gun was small enough to go through the throat of the nozzle, so we wouldn't have to disassemble the engine. So I dreamed up a pantograph machine, got it designed around a jet engine rollover stand for rotation of the entire engine as on a lathe, and built up in a couple of months with 12-hour, 7-day shifts at work, 10 of us working on it. Clint Johnson tried to get a NASA patent on it, but there was a similar but smaller pantograph machine in the 1920s used for coating incandescent light bulbs. Guess we took some business away from RMD, but with 8 engines losing rockite fast supporting 3 airplanes, we did make a real contribution to keep them flying. When Bickle would not ground the X-15s when we came back from flights with the second stage igniter pressure transducer lines blown or detonated, and RMD and the Air Force were slow in getting a diagnosis and a fix, I did get permission to have Rebel's crack machinists to fabricate a 1/2-inch thick sphere made into several pieces so it could be inserted around the lines and igniter and assembled with clamps so we could at least hope to mitigate in-flight damage. We flew with that till the problem could be fixed, which was after the PSTS blew up, as I remember, which got the Air Force moving quicker. My other memory is one that Milt Thompson wrote about in his book, At the Edge of Space. pages 79 to 80, which I'm going to show you. And this is the autograph page in the book that he signed a couple of weeks before he died in August of 1993, on the day that they were to have a big roast, and they went ahead and had the roast that night for him, people coming in from all over the country. But I was in Mill's office when he was signing that book for me, and he had me read these pages, and I was amazed when I read it at the license that he took. I crossed out the top of page 79 that had nothing to do with it, but I won't take time to read all of the text in the book, but basically the story was that he said we had jumped out in the after the engine had started, that we had opened the lid of the pillbox, in which we'd have been dead instantly, and we'd done that due to the acoustics. But he said that he was witnessing, recalling having witnessed my coming out with my headphone cord still connected into the pillbox, and when I sheared off the plug, when I came to the end of the cord trying to get out of the ammonia, because our breath was cut off, and it was so I'm going to go to the next page here, in which Larry Barnett and I were in that pillbox with a couple of inspectors. They had full suits on, and they were out on the airplane, and there had been a malfunction shutdown on the engine, and so with the engine shut down, we went out to inspect it for leaks, or they did, and I was still in the bottom of the pillbox, and we had a big ammonia leak in the ground support equipment, and we had a little water in the bottom of the pillbox, and ammonia really goes for water and in the low areas, and of course we were 6 foot below the ground level in the pillbox, and Larry was standing at the top of the ladder, and so we each had filter masks. That's all Larry and I had, whereas the inspectors had full suits on with full oxygen. And so they didn't get bothered by the ammonia leak, but Larry and I did, and our breath was cut off, and as I remember him falling on top of me, as he was coming down on top of me, I flipped my headset over flipped my filter mask over my headset. And then Larry and I passed each other 3 times going up a 6-foot ladder. And we came out loping into the air every other steps to get as high as we could to get some breath back. And then I came to the end of my cord and broke off the connector in there. And it made me do this flip, and I can't, Milt and I both have the same recollection that I never missed a stride. He says I fell on the ground. I don't remember that. But at any rate, Milt was with, as he says in his book, he was with the producers for the X-15 movie that was going to be made in the next month or two. And so they were witnessing a ground run and what it was like. So we put on a good show for them. And then I say here at the bottom, we had an idea of putting in a manifold and quick disconnects with little egress bottles on the belt of the people that weren't going to have full suits on. And I don't know if it ever got done or not. It wasn't long after that I went to the LLRV. Then another story I can remember is the August, I think it was August, hot day, when Joe Venzel allowed the B-52 to come and land without jettisoning the propellants, because there was an engineer that thought that the loss of telemetering was just a disconnected plug in the equipment bay behind. And so when they came out and landed with a full load, not having jettisoned anything, the B-52 blew every tire in the on the airplane, and the lower ventral was kissing the ground and kissing the runway, and they just made it off the runway and stopped. And turned out there was an equipment fire in the electrical fire in the equipment bay behind the cockpit, so we couldn't put any power on, and so we just had to get all this propellant off, 1,000 gallons of LOX, 1,400 gallons of ammonia, and 100 gallons of peroxide, and had to get all that off safely and with no electric power. And with it fully loaded, we had stress panels on the structure on the X-15, which could not be removed with a full load. And that was blocking our access. But I can remember bringing drawing files down, setting up lights. We were there late figuring out how we could get those propellants unloaded. Fortunately, we got it safed out, but I don't believe we ever made another abort whereby we didn't have to jettison the fuel. The other memories of the high range operation, we would alternate TM launch stations crews between NASA 1 at FRC and Beatty or Ely, the uprange launch TM station, would be in command of the launch, and the control would then pass to FRC at NASA 1 as the flight progressed downrange within communication range. I never made it to Ely, but was at Beatty many, many times. When flight cancellations occurred for weather or technical problems, we rescheduled for the next day. We did not return to Edwards due to the round trip time, so we'd stay overnight. We rarely stayed at the only hotel in Beatty, and which was 115 miles or so north of Vegas, and avoided the only motel north of town where the Greyhound bus stopped at the brothel. Instead, we would pack the station wagon full and head for Las Vegas, about 115 miles south, get 1 or 2 rooms to be shared by 8 or 9 people, and hit the casinos and lounge shows, usually taking in a dinner show as well. The trip back to Beatty for an early launch required the windows to be down for ventilation for most of the time, with a liberal amount of aspirin or whatever to be on the consoles ready for a flight. The transportation to Beatty was sometimes handled by the FRC R4D Goonie Bird, which was the most comfortable way to travel. But usually the Air Force C-130 with a fire truck and a NASA Jeep, the paramedics and the TM crew would take us from Edwards into a 2,000 dirt strip on a mountainside south of Beatty. The Beatty TM and radar crew would pick us up. Going into Beatty, the NASA F-104 weather reconnaissance flight would find us on the mountain dirt road and come in behind our vehicle very low and initiate a vertical climb right over the vehicle, lighting the afterburner on top of the vehicle. Our 3 a.m. waiting room for the C-130 was in the barbershop at base ops, where frequent delays would result in long games of pinochle or hearts. We'll keep the Las Vegas stories mum, but we always had an X-15 pilot with us on the TM ground control crew. They acted as the primary comm to the pilot. I'll tell one story, though, that I didn't write about, and that was, I have to admit, we might have been known as litter bugs in those days, but I can remember Dick Day and I in the back third seat of the station wagon with the tailgate down, and it was our job to get rid of the beer bottles. And so Perry Rao was driving, and I think that he must have been doing 80, 90 miles an hour, which is typical on those lonely desert roads out there in Nevada, and anxious to get to Vegas anyway. And so anyway, on one of our discharges, the bottle hit a road sign. Perry didn't know it. He thought it was a blowout. So we made a command stop in a hurry from about 80 or 90 over on the dirt, all because he thought it was a blowout. So let's go to the next slide. Esther and I took a trip into Niagara Falls in 1999, and I happened to get a chance to take this picture of Jack Russell's plaque in the Hall of Fame. It was housed in Amherst, New York. Of course, Jack was the head of our rocket shop at FRC, and originally a Bell employee on the early X-1 days and NACA days. And anyway, I wanted to share that. This is a shot in June of 1960 of the training class. This is some PSTS personnel at RMD on the workbench, and that was the XLR 99 training class. Here's a nice shot of the X-15 pilots. It's got Monday Morning Hangover on the title on the NASA print. I can't identify, and I probably shouldn't, who they were. Here's another picture of the 6 of the 12 X-15 pilots, of which there's only 4 living today. Another shot of X-15 pilots plus 2 or 3 others that were not flying the X-15. I can see Neil on the left, Joe Walker, and I see, it looks like Butch on the right, Bruce Peterson in the center. Here's Joe Walker, and here's Neil Armstrong, and Bill Dana, and this is Michael Adams, who was the only pilot lost in the X-15 due to a number 3, I believe it was, that crashed, and we lost the pilot. Another pilot shot in front of the FRC. And here's Paul Bickle, who was our leader that really set the example. He'd come over from the Air Force. Bob Hoy and Johnny Armstrong were flight planners on the program from the Air Force as being a joint program. Here is a picture of Vince Capasso and John Reeves getting an award. I believe this was for an automatic checkout card on the engine. And here's the crew chiefs, the X-15 crew chiefs lined up. This is a shot of Norm Foster, who was the pressure suit rep, and had later founded Space Age Control in Palmdale. He had retired, sold his business in Palmdale. Esther and I visited him in Worcester in 1999 on the same trip we made into Niagara Falls. Here's some clips I got out of the X-15 movie, which I think most of us went down and attended in 1961 on the premiere. But Dick Day is over on the extreme left, and then you can see Bill Albrecht and I've got a cigar in my mouth. And here's John McTeague and Bruce Peterson. The rest of the bunch are actors. And here's John McTeague and Bruce Peterson again. Dick Day and Ron Waite. And here's Ron Waite again. And John Palmer on the left, who was a young second lieutenant from the Air Force on assignment to flight ops. And Jim Love over on the right. And the rest are actors again. There's Charles Bronson, the lead man, and Mary Tyler Moore. It was her first movie, the X-15 movie in 1961. Another shot of her out of that movie, and a shot they took staged. And here's one for my 15 great-grandchildren and 19 grandchildren, including Esther's. And it says, it shows Mary Tyler Moore starring, and it shows me co-starring. So that's for my grandkids. Here is a shot, I believe, taken, I took it myself, of the chamber and the engine, or the chamber of the engine installed in the mock-up out in front of the Flight Research Center. And here's my Murphy's machine, and this was a shot furnished by Rudy Wagner, who was the technician from the Air Force that worked on the machine. These shots I just got from NASA DFRC here recently, and they dug them up. But this is the jet engine rollover stand, and you can see the engine is wrapped in plastic. And the another shot with, you can see the gun near the throat area, and the operators watching the coding. Here is a slide. Here's a scan of a technical paper that I found scraps from, showing the spalling of the rockite in the engine chamber. And then this is one that shows the gradation layers in the bottom half of that picture, where we can lay in different combinations of metal and ceramic. And these are off of a film that I'm going to show in this DVD. Later we'll have some films, but it's taken down on Sepulveda Boulevard at Plasma Coat, and we took the engine and machine down there and did the first coating down there. And then once we did that, we turned it all over to the power plant branch, to Jerry Brandt and the Air Force to continue with once we got it demonstrated. Now this is the mural that's in the DFRC lobby, and Robert McCall mural shows the X-15 and a lot of other stuff. And this is the one of the graphics used to show the mission profile, and the model that was shown in a sandbox model, which was pretty good. Showed the B-52 launch and the X-15 trajectory in 3D, and the C-130s orbiting with the paramedics and fire truck and the Jeep that NASA had for recovery. This is an aerial shot of either Ely or Beatty. I can't figure out which. Somebody else may be able to, but they're very similar installations on a mountaintop for the telemetering and communication. And I don't know, this doesn't look like it might be in at NASA 1, it might be, but I see an NACA thing on it, but it's the control room. And what you saw more of in the movie shots. There's a plotter board showing the method of tracking it. Here's a hangar shot of the X-15, and the engine is on a stand behind it, ready to go in. And here's a few clips from Bill Dana's SETP movie that he had presented a paper down there with a movie, and got some clips out here showing the problem areas. And here's a scan of Milt Thompson problems encountered, what they should teach us. And this is a PSTS propulsion system test stand with the XR-11 engine in it, and it was used for the lifting body program. And here's a front end view of the rocket engine, 60,000 pound thrust. And my old friend Wendell Stillwell put out this little almost pamphlet-like book, but as a report. And I had befriended Wendell in the 70s down in Santa Monica. And there's the foreword written by Paul Bickle. But I still have that book in my possession. Here is a scan of a disc that was put out for the June 8th, 1989 30th anniversary. And here's the Valley Press with a picture of the attending X-15 pilots, of which there were, looks like 8 of the 12 pilots. And of course, a few were deceased by then. So I think Neil was the only one living that didn't make that. This is the rest of the article in the paper. And there's Paul Bickle and Ralph Jackson, and you'll see the movie of that on the DVD in a few minutes. And these are just shots of the pilots and attendants and the character generator identifying each of the pilots on the panel. And you'll enjoy them. They're little, they each get a few minutes to talk. So I've got that in my collection. And this is a shot of Jim Love, who was there with Betty. And Esther and I were there at that time in 1989. And enjoyed it. Milt Thompson and Pete Knight and Bill Dana. And Joe Engel, Bob Hoy, and Milt. These were all taken at that dinner in 1989. Dick Hallion, Chief Air Force historian, and a shot at the table. And Scotty Crossfield. Milt, and the widows of Mike Adams, Joe Walker, and John McKay, or Jack McKay, receiving their awards. Milt, Pete, and Bill. And Walt Williams. And I got to take a minute and tell a story about Walt. He had been director at FRC before Paul Bickle came over from the Air Force as chief engineer over there and took over. And Walt went in to become the Mercury project manager for Project Mercury. And he came in and joined us for a post-flight X-15 briefing. This was some time before Alan Shepard went, because he was reporting on the chimpanzee flight that was launched on the Redstone. And I've forgotten the chimp's name, but he told a story about them having trained the chimp to push certain switches, and he got a banana chip. And they had thought they had exposed him to the various flight environments, but they had forgotten one, and that was that they hadn't exposed him to the escape rocket tower, leaving the capsule after a successful launch. And but the chimp had learned to beat the system, and he didn't have to go through all the procedures that he was trained to do to get his banana chip, because he had a shortcut that he had developed. Well, Walt said that they had the film footage of the chimp during the launch, and when he was getting his banana chips with his shortcut switch procedure, and then when he got to the escape tower portion that he'd been never exposed to, when that thing took off, he got so scared that he started going back and getting his banana chips with the standard way he was taught. So it was a very interesting observation. I always remember that story. And here's the astronaut wing presentation made in 2005. And there's Johnny Armstrong, and gave a nice talk, and John McTeague, and Vince Capasso, and you'll be seeing that. And Neil Armstrong was there at this one, and Bob White, and Joe Engel, and Bill Dana. And here's the chief of the astronaut office, Kent Rominger, giving the widow of Joe Walker, Grace Walker Wiseman, with Joe's wings, and that's Vance Brand on the left. And then Joe Walker's son, Jim, and Sherry McKay Lowe receiving Jack's wings from Kent, and Bill and Judy Dana. And I get to see Bill here next week, I hope, because he just moved into Peoria in a senior facility in Peoria, Arizona, and that's just a few miles from where I live. And here's John McTeague and Betty Love, plus some others in the audience, and Bill and Judy. And there's John and Vince, Bill Dana, and Johnny Armstrong, Neil and Joe. And there's the engine, and the PSTS, Propulsion System Test Stand. And there's the rocket firing, the XLR-99 60,000-pound thrust. Every diamond, shock diamond there is a Mach number. And the hangar shot, and the servicing shot on the wing of the B-52, and here it is, a taxi shot out of the movie. And the launch, I think he's just dropped off the hooks there in that shot, Here's it may not be after launch. This is a close-up before launch. These are out of the movie. And here's a close-up of the logo on the fuselage of the B-52 with a nice little cartoon. And here's the prime before the drop. This is out of the movie because it's got the HD format. And the contrails. And this is out of the windshield of a chase, looking up at the prime. Belly camera shot. And a little later, as it's dropping and getting the engine lit, losing a little altitude till it can get it lit. And there you are through the windshield of the chase as it lights off. And it's taken off with about a 2G forward acceleration. Weighs about 30,000 pounds full of fuel at launch, and with a 60,000 pound engine. It's got a 2G acceleration. There's a contrail, and it moves out pretty fast. This is again out of the movie. These are mixed up, not off the same flight. Here's a shot from the rear camera looking over the fuselage at the control surfaces. And Betty and I used to look at all of these films after every flight. I can't remember. There must have been a dozen cameras, if you count the B-52 cameras, the chase cameras, and the several on board the X-15. And we'd be looking for leaks and whatever we could find on the external surfaces. This is a shot from high altitude looking at the, and there's a nice curvature of the Earth as it's getting up into the 200,000 or 300,000 foot area in altitude. And here's a landing, and the ventral is just dropped. You can just barely see it with this long shot. And the parachute that recovers the lower ventral off the tail. And there's the skids out. And you can see the carry-all there that through the smoke flares near the touchdown. Here's the nose gear down as well as the skids, and here you are, touchdown with the skids, and then the nose comes down pretty fast. There's another shot I slipped in. Here's the chase, a nice shot of landing with the chase right by him, and the dust rolling. And now here we go to ship 2 with the drop tanks, which added some 30-40 seconds to the burn time so we could get out. The goal was Mach 8, but never quite made Mach 8, 6.7 I think. There's the eyelet on the windshield because we found they found that the windshield would with the ablative coating would coat over, so you had to keep one window with the eyelet closed so it wouldn't get frosted over from the ablative coating, and then open the eyelet for landing so we'd have some visibility to get the thing landed. Here's a nice shot with a ramjet showing underneath that was supposed to be tested out to the Mach 8, and there it is. I don't know if that's in the process of dropping the ramjet. I think it is. And there it is, yes. So it's going to be parachuted down. Here's the ablative coating on the same airplane with those drop tanks. And there it is at launch, getting lit off. And this was a model used in the X-15 movie to show the heating on the structure, but that was a model shown with the colors on it. Here's a nice shot with the aft skids down and the nose wheel still ready to drop and come in, and a shot, this was from the movie, on the tail end after it landed. And now we start the little mishaps, some major, most all of them were major. This is a shot of on the top of Scotty's broken back. That would have been with the little engines before we ever got the big engine. I was on Rosamond Dry Lake. The bottom is Jack McKay's Mud Lake. No, that was X-15-3 on the test end that blew apart. here's a close-up of the broken back on Rosamond Dry Lake that Scotty Crossfield had on the early flights. And this is out of the movie, and this is a series that's starting the, there's a pilot in the cockpit. I think that was probably an actor, but it shows the frost on the LOX tank and the run of the engine, and a view from inside the White House, and then the airplane when it blew up, and regulator and relief valve and ground support equipment on the ammonia servicing equipment all combined into failure, but it blew apart right at the aft edge of the wing. These are movie shots. Those were reenacted, of course, but this is a real one showing the airplane, the front part of the airplane with the cockpit severed there at the aft edge of the wing. And the when the ammonia tank blew, it shot the helium tank and the cylinder in the core of that ammonia tank into the peroxide tank. The peroxide blew, and that's what blew the airplane apart. There's what's left with the tie down on the back. Now, here's a series of flights in which we had, I think, Johnny Armstrong told me 10 emergency landings uprange, which saved the airplane every time. This is one that went into Mud Lake. What happens with an emergency landing, you can't get the engine running, or it quits soon after it starts, and you've got just 3 or 4 minutes to get rid of 15,000 pounds of propellant. You'll be on the ground, and you got to get rid of it. In this case, this was a very successful one, and it's my favorite shot of the looks like a T-38 tucked in with the X-15, and shows him going into Mud Lake and touchdown and normal landing on the emergency lake bed at Mud Lake. Now this one wasn't quite so successful, but the pilot did live, and there's a shadow taken a few seconds before touchdown, and there were no other pictures, but there's the skid marks of Jack's landing, in which he tipped over at the end. He had lost the nose gear, and the left skid had a fatigue crack in it, and he was heavy. The flaps didn't work, and so he came in and touched down, I think, about 400 miles an hour, and within 12 seconds was upside down and had taken that path. These are shots of different angles of the airplane, and as I recall, when the rescue crew arrived to get Jack out, the ammonia was so bad the helicopter had to go in and use the wash to blow the ammonia away so they could get him out. And there's a shot of the headrest into the dirt and the rail at the very top, and you could see they had to cut the hoses so the rocket the ejection seat rocket wouldn't fire. Cut the hoses, cut his straps, drag him out through that narrow thing, and he did have some fractured vertebrae, and he did fly the X-15 afterwards after he recovered. However, he had lost 2 inches in his spine, and due to the compression. Here is a shot of the flap actuator showing the failure of the balls there in the bearing on that, and the switch showing in the cockpit that it was actually operated properly. And this is the crane picking it up out of the movie that I had a clip of. This is an igniter, scan of an igniter explosion on the engine, and this last piece is the F-100 that was used in the movie. It was actually some Air Force footage taken, I think, years before, but as I recall the story, Bill Dana knew the pilot, who was a ferry pilot working for North American out of Palmdale, and was hired to ferry this F-100 back east somewhere from the plant. And Bill had known him in the Air Force, and I think had washed him out on his flight certification or something. And then, but he did get his job as this ferry pilot and had a problem, couldn't handle it. Came into Edwards, and this was a terrible crash that they used in the X-15 movie as a dramatic. But these are stills taken from that. And on December 9th, 2008, NASA JSC Altair Project Office hosted a one-day conference for the Apollo team to share their experiences for training for lunar landings. Here are 4 clips taken from that conference from a 3 DVD set I produced this year. You can see the attendees on the Apollo team. We had 4 moonwalkers there and myself, the NASA Johnson Space Center team, and then the NASA Dryden Flight Research Center team. Here's the first movie clip.
Anything else?
Well, I envy the technology available. Simulation can be worlds better now than it was 40 years ago. And that's great. You should take advantage of that. You will, I know. The LLTV, if made today, I would hope is an order of magnitude better in both performance, reliability, and so on than it was in our time. Should be. It would make a big difference. And it's your job to sort through all these options and come up with something you can afford to do, and that will provide that level of confidence on the parts of the crew when they get there. I feel pretty good about the fact that you've got a process going that will go through this and hopefully come to a conclusion that gives you the confidence that they will feel very comfortable when they're on final up there. Like this is just like what I'm used to feel.
Yeah.
And I think you can do that.
And all the crew source training management, man, I expect what Jack and I did in the simulator against anybody working together, problem solved in dynamic simulator environment conditions. You can't, you just don't have time, you can't get that, you don't need to get that on a quote LLT type vehicle. And I heard things about risk. You know, John said we'd crash 2 or 3 more before we got to the moon on Apollo 20. Maybe he's right, I don't know. I'd rather put myself in that risk environment here to give myself the confidence that I can handle the same risk environment over here. It's worth it. I don't want to put him in it with me. This helicopter last thing came potentially closer, but I think if you have the ability to go, I'm not even talking about cost, but the ability to go one step closer to the real world, you ought to take it. It's too important of a trip. You got too much at risk.
Right.
You got too much hanging out there. You ought to do as much as you possibly can within the Earth environment to simulate the real world as you possibly can.
Where our team
within your confines of cost and risk and however else you want to put them all in the pot evaluate.
Cost aside, the gimbal jet vehicle is the most analogous to the job. That's where our T landed.
see, you're dealing, and I want to compliment you for what you're doing, because to look at all these concepts, and it's been for me, a very educational day. But you're dealing in a world of technology which is eons ahead. This world of digital technology, I mean, eons ahead of where we were 40 years ago. Take advantage of it.
A lot better understanding of what the landing site looks like, and maybe some navigation aids on site to get us in there, right? So we ought to factor that in.
So what you're saying, Kathy, I agree. What is your interpretation of what this says? Does this mean the LLTV was too risky to use, or does this mean it was important to use it to understand how to fly? I'm worried. I'm troubled that this could be misinterpreted.
I don't have any idea what they.
For me, it's about they're describing the experience that they felt in landing the lander. In landing the lander or flying down. Their problem was they didn't. I don't think they had the information that we will have about the landing site. So I interpret Neil's comments is for him getting the visual on the site and the lay of the land was incredibly important, because there was a limited amount of information of what the site looked like in advance.
And you're dealing with the fourth dimension of time, which no one seems to talk about much. But you don't have a lot of time to change your mind. You got to make the right decision the first time, and your visual cues are so important. I know that Dave strongly feels the way Neil and I feel about this. So when he says zigzag, even if you said, I don't want to land here, I want to land over there, you're going to make a nice, smooth, it's like flying an airplane. You don't yank it over, you're just going to fly it over. And so, I don't know exactly what he
was talking. I don't either, but I don't think you should take it literally. I think what he was trying to say is kind of a difficult task.
Yeah, exactly.
Well, Neil, I think you were quoted as saying on a scale of 1 to 10, the landing was a 13.
Made easier though with a little training.
I just don't want it to be interpreted in a way that it says the training is too high risk to be able to perform.
No. I think where I just wanted.
I think you're making a big mistake just having LLTV. We crashed 3 out of 4 of them. You're going to crash 4 out of 4. If we'd had 18, 19, 20, we'd have crashed 4 out of 4 of them. And I think you don't want to build an LLTV. You want to use the damn simulator.
Let's
John,
say
I was next in line to crash. Give you a break.
I'd point out that if you look at the details of each of those crashes, we should easily be able to avoid those.
Yeah, but what you need an LLTV for the simulator.
Well, let's talk about that this afternoon.
Hey, John, you guys.
Scares me though, is your time frame. That was the third space vehicle that was designed in rapid fashion. We haven't built anything but a bunch of paper slides in a long time. And the one benefit I think we have with F-35 coming along is at one point there was enough competing companies that they all were seriously considering design of VTOL type systems and how they were going to integrate thrust vectoring and stability and control with different components. That maybe that'll help us, but we don't have the corporate knowledge and the generations of learning and all those, building a new vehicle once per, a new aircraft one type per year coming off the production line. We've got a staggering industry, and that kind of scares me. So, it may be up here, but we building real hardware we're now.
How long ago the X-35 moved compared to, it's still in development. It's come a long way, but development takes forever on stuff. That's why I say you need to start the RV sooner than later, because it will take a while. It's great stuff, but it's still going to take a while.
don't underestimate that industry, but that's one reason why you guys, all you guys and gals, really need to keep your nose involved with what they're designing that you're going to stretch your butt to do and train with. Doesn't make any difference. You really need sometimes to be a pain in the butt. But you know, I hired an engineer when I graduated from Purdue, but I didn't know how to spell it. Okay, and you're going to use it. Or those who follow in your footsteps are going to use it. You owe it to them to make sure that they've got what they need to get the job done, not what someone thinks they need. And I say that in all reverence to, I'm an engineer too, so I can say that. But sometimes engineers come up with great ideas, but when you put them in the cockpit, you can't reach them, you can't touch them, they don't play together in one thing or another. You guys are responsible to make sure they do. And that is so important. If there's one thing that made a difference, Neil's involvement in the LLRB determined the way we would train for the rest of all of the flights. And a testimonial to the work he did and everyone else did. Everyone, think about this, everyone we sent to the moon, including Apollo 13, came home to talk about it. I'm not discounting Apollo 1, but every flight we sent to the moon came back. And that's a testimonial to that industry you're talking about. It can be done, but there's a lot of people that have to make their worth known. But I want to go back to what I said. I don't know if all of you were here this morning. Going to the moon, from the time you lift off to the time you complete that landing, is a necessary evil. It's fun. It's a challenge. You'll do it if you get a chance. But it's a necessary evil. The idea in today's world going to the moon is being there. Being there. So make the trip from beginning to touchdown as safe and as simple and as uncomplicated and as cost effective as you can possibly make it. And take all that talent and all that technology and put it to work on the moon. Put it to work where it counts. Going, what did we do to occupy our time? Oh, you'll find things for those 3 days. We'll do some experiments. We'll do a few of those. But you know what? We did them because we had the time to do them, not because they were really part of the program. We were there, and Neil's major objective was to get on the moon and get home safely. When we got back down to Apollo 17 is get on the moon, make use of your time while you're there. We threw the technology of a lunar rover on the moon, gave us tremendous capability. All we did was build on the same technology that Neil used to get there. We didn't change anything. We didn't change a thing. Oh, the lens was a little bit heavier lift capability, and one thing or another. We took the tools we needed to do something special when we got there. And so I really emphasize, just think simple and safe. That will automatically make you cost effective, I think,
Yeah.
and we'll get the job done. And it could have made your job easy today if we all said we don't need a flying device. We don't need it. Just go straight from the simulator to the moon. But that would have made your job easy. I think what you heard today is we strongly support some free flying devices. Helicopter, LLTV, kite with a string, I don't care what it is. You figure it out. You heard what we thought.
Right.
But I hope you come out of this meeting with the fact that based upon our experience, we feel a free flying device is extremely valuable in our training to get us to the moon.
Right.
I mean, I hope you come out of this with
Oh,
that.
definitely, and a free flying device that does not meet the end-to-end totality of requirements to prepare you. A free-flying device that has
You figure
certain
out what it is.
characteristics, right? That has
You
certain
figure out what it is.
characteristics.
You know,
Right.
we took it what we
No, I
thought
think that
based
was
upon
very, very
what we
clear.
had available, which was obviously adequate, and go from there. But I do hope you come to a conclusion that you need to fill the gap. You know, maybe there's a couple other things that allow you to fill the gap between a T-38 or a lunar or a simulator and in the middle. You know, maybe it's a little helicopter, maybe it's some other kind of device, and maybe it's eventually something. But I keep saying, don't get too sophisticated. Stay simple. You just don't have to. You don't have to recreate the world here on Earth just to go to the moon.
I think this is a very important thing, is that one reason why you almost, the chances are that you'll have manual landings is because you can start your manual landing in a controlled situation, not an uncontrolled situation. You need to bear that in mind. It's not really on your list, but it's an important point that's been made several times.
I think the thing that strikes me is how big an advantage you have over what we had 4 years ago. How little we knew when we started the LLRV. You know, we were stability and control guys, and we did a lot of dead stick landing, kind of landings where our world, boy, we could do all kinds of landings, but the stick force per G and maybe over TV and all those things we used, none of them fit. You know, we had to start from, we didn't know anything about that. We were just, and we know so much more now than we did. So you're starting from such a high plateau that what you have left to go seems minuscule compared to what we had to face.
I agree with you, and that's what I struggle with an early start on an LLRV. You know, what for? You know, what for is the question, and that's where I think the information that you're going to prepare to Michelle, you know, provide to Michelle will help us get at our risks, and we can things
we'll
that
be
are
able
keeping
to
us
match
up at night,
those up, I
and
think.
see are there things that an LLRV can help us with that are aligned with the things that are keeping us up at night.
I don't know if there's a way for you to afford to get some preliminary work done on whatever configuration you choose. You haven't got the money to build it right now to buy it, but you can get some studies done to give you a little more meat to work with.
We're starting to suggest some things.
But my sense is too, you know, following on the point that MASH,
Hopefully never smash.
with a guy named Scorch.
Smash and score.
Yeah, not the guy.
Got big
Well, we're here for
Big
a
Send me your fighters.
But you know, I think we have a very constrained budget in the next couple of years, and so what I will struggle with is what are investments that you can make now to help make decisions in the future that you won't regret because you made them too soon, because you don't understand the task, because you don't understand the approach profile, because you don't understand a number of things. So there's some big items hanging out vis-a-vis our design, our concept of the vehicle, that make me say, well, you know, this may or may not, this one may be at risk because if I go down this investment may be at risk because if I go down that direction, you know, this data, I don't need it anymore. So trying to find the investments that are affordable in these next 2 years that are extremely cost constrained, and that you're sure that the investment will be used in future decision making, are the challenges that we have at this point in time.
So,
And I can tell you, talking to Dave Scott and Dick Gordon, they feel strongly, I think, very much the way we feel.
Dick's, or actually, Dick's and Dave's comments are in the report. I would encourage people to read those if they have other inputs.
Okay, let me take the opportunity to go around the room and see whether anyone else has a question or a comment or something that they heard that they just are dying to follow up on. This is a rare.
I'll take the chance. I just want to re-emphasize the fact that we did have an early start. We beat the LEM design with our LLRV design and flying, got it started. And we did contribute a lot to Grumman on their design with the DDT&E, with the LLRV. Made some, and I'm following up for Michelle's request yesterday to offer you some documentation from the 60s that'll more definitively define that. But I just want to encourage you to keep in mind, the earlier we can get started on DDT&E with a new LLRV, that'll help reduce the risk on the DDT&E of the trainer and the Altair itself. It will really pay off as a return on investment. And you don't want to delay it for any reason to get crammed into like we were in certain situations in Apollo where we made some sacrifices because we lacked support, lacked funding, schedules were compressed, and we were always under the pressure. And Neil can speak to that with his having to give up the bulk of his training until a month before he launched. Back to the early start. In Apollo, we got started in the LLRV, as I said before Grumman started the design. Where we screwed up was waiting too long on the training, because I remember when it came to getting the trainers kicked off, Bill Giesel up at Bell had to cough up about $1 million to buy long leads 7 months before he ever had a contract for the trainers. That could translate to what, $20 million today? What contractor's going to do that today? So just take some lessons, get started early, because you don't want to get into that kind of a box.
Right. Okay, that's good.
You didn't tune me out when your decent rate was 16 feet per second.
But I knew it was. But I knew it was, and I knew what I had to do to stop it, because I'd been on the LLTV. And I think you've heard a lot about, it's amazing. Neil and I haven't talked about this in 40 years. But his thinking and feeling, surprisingly enough, and he said a couple things the other day, man, which hit me right on the spot, exactly. So we did this 40 years ago, and 3 years apart, and sure we debriefed, and but his reactions, responses to his training and his landing were almost identical to mine.
Yeah, that's significant, I think.
Walking away from here, I think Gene did a great thing for us earlier when he said, sim, flights. You know, if we looked at this from the same perspective, how would you guys, I don't want you to go through the exercise of prioritizing, so to speak, but are there things here that are nice to have versus absolutely necessary from a flight?
Well, they're general categories, and we'll have to consider, you know, how they would map into a fixed base.
But gravity offset, for instance, you know, how imperative is that?
I think I heard
Field of
someone
view,
say earlier
obviously.
that it was pretty important.
Well, it's going to affect how long you have to sit there and wait to move a certain distance, and you're doing that in a time-critical situation where you're running low on fuel. And I would think, unless you can decouple and pitch and roll, you're not doing a very good training job.
Anything else? Do you, Clinton, any wrap-up comments?
Nothing more than just expressing my great gratitude for you guys taking the time. I mean, this is exactly what we wanted to try and get out of the meeting, and likewise to you guys sitting here. It's helped immensely, I think, John, because this hits our expectation and exceeds it. So this is valuable information for us for the future, and I think we got the message. I think most of us sitting here agree with the, I don't know about the kite and the string, but absolutely the, with the fact that we need something, and so what we get to have fun doing is figuring out what the something is.
In reverse, it's nice to know that you're still loved and wanted.
I don't know about the love.
You know,
Obvious to me.
And we're gonna, it won't be long, and there's gonna be fewer of us here. You know, and if you waited another 5 years, you may not have as many of us to talk to. Another 10 years, probably less than that. And God knows in 20 years, we'll be looking down from somewhere, I suppose, watching what you do. And,
Looking at me down.
Yeah, but you'd be blabbering and slobbering and all that stuff. Seriously, to be able at least to give you our opinion, do with it what you want. Do it. We, you know, other than a strong support for what you're doing. I personally don't have a dog in this fight, and I just want to see you be successful. And if what we say taints or your opinion one way or the other, use it in a manner in which you want. Like I say, from a technological point of view and from a capability that you've surrounded yourself with these kind of people, you're a winner. You can't lose. And don't think we're absolutely right. Just say, you know, on the other hand, this is not a history of simulation. This is a history of 6 successful lunar landings. And so someone's got to say, hey, they did something right.
Right. Well, I mean, you gave us a tremendous gift in making our job easier by having done it all those years ago. And you continue to give by your willingness to interact with us as we try to redo it in this day and age, and solve the same problems with new technologies in a different time. So we're really grateful to you for taking the time to come here. And I would go so far as say loved. I would go so far. But I'm a woman, so I can.
I tell you what, if you're here in 10 years, I'll be here in 10 years.
Okay.
Because you were first on the moon. All I did was follow in your footsteps, so that's the way it's going to be from here on out.
I hope Gene is absolutely right about the timing and how long they're going to be around, but I just want to share with you that out of a number of key people, we're losing them at 3 or 4 a year on this program, either Alzheimer's or death, and it's the sense of urgency on me is it's very urgent to capture and get all this feedback as early as we can.
Ask a question with respect to, you guys saw the height of the deck in the simulator. I mean, how does the height of the deck want to drive your implementation of this vehicle?
The what, Kathy?
The height of where you are. You're
Line of sight.
6 meters, 6, 7 meters above the surface when you set down. How does that want to drive the geometry or the design
it's
of
a
this vehicle, a
interesting-
gimbal jet vehicle?
Interesting thing to bring up is your perception is based on the environment you're used to working with, or working under. As much as I hate to say Howard might have a point on the simulation side, that's one incredible thing you get, because basically if you're used to, if you were to fly a low level on the East Coast with big pine trees and everything else, and go out to the desert and try to make the sagebrush look like pine trees, because that's what you're used to visually, you'll be scraping the dirt.
Right.
And so, your visual perception, or where you actually put yourself height-wise, may be a completely different sensation in the real environment as opposed to what you end up with otherwise, what you train with or what you maneuver. So I'm not sure that you can necessarily mandate that.
I'm just trying to value it when we start getting evaluation criteria. How important is that in this kind of a vehicle?
We go
Yeah.
Lower
But
priority.
I can mention that, Wayne, correct me if I'm wrong, the LLTV versus Apollo was about 1/3 the height difference?
No, about 1/2.
1/2. And future contests are expected to replicate that, about 1/2.
Yeah, but as I remember, we could look out those LEM windows and have a fairly direct view to the surface, and we're sitting at the front end of the LLTV, and we have the same view down the surface. You put yourself behind that big old platform out there, you're not going to look this way, you're going to look out there. And my thinking is, for a training device, you want to blank out that area. Now you got an aerodynamic problem because of but somehow, would it be an absolute requirement? Probably not, but it sure, more than the dust thing we talked about, for me, it would be nice to know what I'm not going to see. Of course, you get that in the
That's what I'm wondering, Gene, if you don't.
You get that in the
With
simulator.
1,000 hours in the AMS, if you're not going to pretty well have that visually.
Yeah, you're right, Jack. I think you get most of that in a simulator
You
itself.
listed the variable.
Because then
nicely.
you compromise and you put yourself at a higher risk factor if you try to aerodynamically put some kind of shade up in front of you.
Yeah, you would.
Right.
I think that I wouldn't want to do that. I'd rather train without it.
The other.
The thing about being so high in this vehicle, you're just going to have to convert your computer up here to the actual motion across the ground. The closer to the ground you are, the better you know how fast you're going, left, right, up, down, whatever. The further you're away, the more difficult it is, and that 30 feet versus 20 feet is probably going to make a difference. But the guys will get that. They'll see that in the LMS.
Yeah.
In the simulator. Higher, probably knows about how much higher than if he flies at 172.
But from your all's training and perspective, that came from the LLTV.
It's a combination.
Came from a number of things, I'm sure.
Regina's saying it's a combination of experiences.
Combination of helicopter, I think helicopter,
Okay. So you're saying
LLTV,
you really
and
experience it on other vehicles.
fixed base simulator, visual.
Offhand, I don't see it to be a problem.
I don't either.
We do that in aviation all the time.
All the time.
Different kind of vehicles, different cockpit heights. But I might be overlooking something. There might be something that I haven't thought about. But offhand, I don't see it as a problem.
I don't either. I don't want to simplify it, but once you get accustomed to that environment that you're going to be part of, you know what to look for, what to feel. You've been there before. I mean, if you're landing 30 feet above, you're touching down 30 feet above the surface, or 5 feet above the surface, you know what vehicle you're in. You know how it's going to respond. You know, it's just.
But it was how you get that experience before you get there. So I understand your answer.
All the pieces.
Yep.
Visual simulators. I think LLTV.
Okay.
The helicopter.
The LMS was good.
LMS. The whole thing. The whole thing.
One thing I haven't, thought about or experienced, but I think you'd get this in the process, but it's a taller vehicle.
Right.
And so, and I don't know exactly where the CG is and so on, but sometimes the amount of motion that you get at the cockpit is different than the amount that the footpads are seeing by a substantial margin. And you have to get a sense of that to know how careful you have to be up on top to make sure the bottom is doing the right thing. But I think that, I don't see it as a problem, I just see it's experience and training that'll make you.
Exactly. As far as accommodating the distance you are from the surface, it just comes with experience and training.
Our Apollo LLTV was about half the size dimensionally of the LEM, and our proposed design for a new version LLTV is about half the size of the Altair. And I think, relatively speaking, if it worked in Apollo, we hope it'll work in Altair.
You accommodated the LLTV, you accommodated the LMS, you accommodated the lunar module.
Yeah.
The Altair simulator, I think, gave a good perspective with the television displays and the windows and everything on that, both rates as well as height above the surface. That was pretty good.
I know that if I pitch 10 degrees, I'm going to start moving at some rate that I expect to see. Now, if I'm in the LLTV and the CG is, if I'm standing on the CG up there, when I pitch 10 degrees, things not going to be the same. Okay? They're going to be grossly different. What I'm going to get for what I put in is going to be different. That's all I'm asking. Does that make a difference or not? I want to know what to expect for my inputs.
It's a good question. We had the same one. And again, if we can incorporate that feeling in there, we should try into the vehicle design.
And it may be so close it won't make any difference.
I don't think it's going to be a big deal.
That was all incorporated in the STA, went to great efforts to have it in, put inside force controller, built the first two airplanes, flew them, but took them off.
Didn't make any
The crew said, I can't tell the difference. It's
Okay.
one way or the other, they don't matter.
I think that's a good
Money and
point.
take them away,
My sense tells me it's not going to be a.
The hardest landing we had was one where
Okay.
the commander experienced some hard side.
So there's some.
One last question here. Does it matter if you're seated or standing for the training vehicle? No, I'm not talking about that. I'm talking about.
You mean from a fidelity
fidelity
perspective?
Fidelity when you got into the lens coming down.
Is that name? So
In
the
that
guys-
case, I don't
this your
think it
pen?
was important. The reason I say that is that my upper torso was rigid with respect to the visual reference that I was looking through. And from the waist down, what the configuration of my appendages were wasn't too important, but I think I could have done it in a kneeling position, or feet out front, or maybe even
Is the kneeling position a pun?
prone.
That's a good input.
So,
One last analogy too is we train repetitively for athletes. Like you say, we spend so much time trying to just get there, get into just into lower orbit. In this case, we're station. We spend the majority of our training that's probably 60% is depleted in the first 8 minutes of the mission. You got 2 weeks left, and you haven't even practiced that part. So that part is fine. The thing that nothing really prepares you for accident. When you watch gauges move, you watch things happen. They throw malfunctions at you, throw switches, you do much crap. But until you get the pumpkin suit on and you're really thrown in the seat, you're being chunked around on ascent, and your eyeballs are this big. It's not an environment that is adequately simulated from the dynamic motion point of view. Entry is a little better. I mean, when you practice repetitive STA runs, we do suited STA runs, and you're used to kind of staring down at the pedals, and you feel what 100% speed brake may feel like. You're being pushed forward in your seat. There's vibration from the thrust reversers, just like you get a little vibration from the airframe. I mean, you feel like you're there. You feel like that's home. When you're doing the KSC, and that's where you actually land, there's nothing better. That's almost a one-to-one training environment, and that makes it very simple. The other analogy I had was basic carrier training. We were in the time frame when we were just doing 2-seat A training, A-gate A, and then you get thrown into the A-gate B single seat the first time. And I learned, I memorized everything, every muscle movement I had to make. But until you get that eye-opening awareness of acceleration on your body with greater than 1-to-1 thrust of weight, you haven't lived. And so you've got to experience that. If there's a way to do it ahead of time, it'll just make your job that much simpler.
Going in today is whether you need to fill the gap between a simulator and the real world. I hope you got the message that it's yes, which is shorter with John's feeling. John doesn't feel it, but that's his opinion. And John's sure flown a lot of space flights, including the STA and everything else. But would John have liked to fly on a shuttle without the STA?
He said no.
Would the shuttle simulator been enough for you guys to go and fly? Well, there's your answer.
I think his bias on the LLTV, from what I understood, was a safety one.
Yeah.
He didn't accept the assertion that you could make it safer than the one that you guys flew. So given that assumption, he said, for what I get out of it, the risk for me, I wouldn't take that trade. I wouldn't recommend going.
You think of the time frame this was happening. In the 60s, we were dropping airplanes left and right. New aircraft designs, pushing the edge of the envelope on stuff. They didn't have all the...
In the time that we had our 3 crashes, they had several fatalities in the T-38s and lost some helicopters.
I mean, you two are the guys that might someday get the call to actually go. Sit across the table. What are your thoughts? Probably too low.
Right.
So, Master, if you're going, what do you want?
I think once we know the task well enough, I think we need to pursue a flying vehicle, and the LLTV seems to me to be the best option. And I think we can do it better today, but I want to understand the task better because.
Before we move on, when we briefed this to the career office several months ago, they brought up one of their key concerns was where you're feeling the thrust. Is it the seat of your pants?
Where you're what?
Where you're feeling the thrust. Is it at the seat of your pants, or is it in a helicopter? Is it a different location? So I'm wondering where in here is that? Would that be captured on the list? Or is it?
Yeah, Brad, I don't think we did actually. Maybe it falls generally under motion cues.
And then also I'm wondering for these gentlemen, would you consider that to be important as well?
Your feeling of thrust?
Where do you feel the thrust? So on the LLTV, you've got the gimbaled engine below you, like you would on the actual limb. Whereas in the helicopter, you've got rotary above your head. So.
I think generally the feeling is the same, but the rocket engines typically have a lot faster response than either an aerodynamic surface or a jet engine. So you have a feeling, if you have a rocket engine boost, it's very crisp, and you notice instantly when it hits, because it doesn't come like this, hit you. It's like that, very, very quickly. So that's you should try to, whatever simulation you have, you should do your best to try to match as well as you're able what the altimeter.
You're not really feeling the gimbal jet. You're feeling those lift rockets on the outer frame that pitches with you.
That's fair.
Al, did you want to say something?
I just want to follow up on something you hit on a minute ago. Originally, it was like a discriminator between whether or not you use an LLTV, but it seems to be more a discriminator between this gimbal jet concept and the other two helo concepts, and between the gimbal jet concept and the STA. It's this idea of the reset button, and the fact that this gimbal jet concept, like the LLTV, doesn't have it, but all the other ones appear to have it. How important is that really?
Well, I use the reset button as just an example. You're in a simulator, and you screw up, and we screwed up and blew up and landed hard and screwed up malfunctions and one thing or another, and that's what simulators for. And you do it again, and you just stop. Let's go out, have a cup of coffee, and talk to the instructor. Where did I screw up? How could I have done it better? What did I miss? What did we miss? We're a team in there. And so then when I talk about the reset button, that's what I refer to. But I'll go back to something, what is it? Scorch. What you said earlier. You go out in the STA, you're planning to shoot 10 landings, right? You said a minute ago, which one's the most important that you prepare for, that you're most focused on? It's the first one. That's your first shot. And that's what I'm trying to say. You don't have a reset button in an LLTV. You don't have a reset button in a lunar lander. That's the first landing, and it's got to be the one you focus on. And the fact that you don't have a guy who can, a safety pilot to save your butt, the fact that you can't say, stop the world, I want to talk about this thing I just messed up on. You don't have that. You've got
3 minutes remaining. This conference is showing no activity. If you would like to continue the conference, please press.
I mean, it's a philosophical thing, but you brought it home to me when you said, I'm going up to make 10 landings in the STA, but man, this is the one that's going to count. The first one. That's the one you got to make happen. And the LLTV puts you in that psychological environment. I'm up here. I got to make this landing. Ain't anybody else going to make it for me?
Would that be a discriminator?
And that's where you are when you're on the moon.
Would that then be a discriminator against the sky crane and then the other helicopter and then also the STA then? Because they do have the safety pilot.
I'm not against it. All I'm saying, if you want to throw a safety pilot into the system, throw him or her in. I'll be careful. I use the word him generically. If you want to put a safety pilot in the system, put it in. If you can afford it, makes it less risky, that's fine. All I'm saying is you're giving up a valuable part of that simulation. And that's the psychological effect of taking it one step closer by yourself. You kind of, but without mission control, without everything, by yourself, one step closer to the real world of landing on the moon. That's all I'm saying. That's me. Other people may disagree with that. If you put a safety pilot in, fine. You lose a little, you reduce the risk, you gain safety, you spend more money, but you also lose what I think is a very valuable part of the LLT simulation. And that's having to do it.
And you could increase mission risk because you did it that way.
Pardon?
you could increase mission risk because you did it
That's
that
the
way.
point. I want to take the risk here.
Right.
Right.
I can get out of screwing up here. I can't get out of screwing up out there. It's
One minor point. This throttleable, gimbalable engine. That might have an effect on vehicle motions such a way that you want to somehow incorporate that in the simulation. I don't know if it will or not, but you need to know whether it will or not. So you might go on the track of finding out to what extent it might affect the simulation and how, so it could be implemented if it was important to do so.
See, in all simulations, we can freeze time. You can't freeze time in the real world. And the LLT puts you in, quote, that real world. Is that valuable? I think it is. Other, you all may have your own opinion on it.
This is appears to be a discriminator between these two concepts. That's why I wanted to bring that up.
But what I do want to go back to is how much this in-flight vehicle, if you really want to do this, would have to simulate the visual cues. Because they're the drivers on this, to me, they're the drivers on the psychology cue. If you get to the moon, I'll bet you, I'd even money, if you flew your LOV and I got somebody in a ground-based simulator and I made the visual cues so realistic that when he got to the moon, it looked exactly the way it had looked to him in the simulator, that he'd feel really comfortable. Okay? And so what I'm trying to suck out of you guys is how much we've got to do in that in-flight simulator visually to make it like what you got to on the moon, and how much we don't.
I just off the cuff answer.
Yeah.
Well, that'd be great to have that high-res visual, and undoubtedly that would make that aspect of the training immensely more valuable than it is now. But it still misses a lot of things.
I'm not saying, I'm just asking for the training.
Motion, you hear the rockets coming from where they're coming, and you don't get that. You don't have that feeling.
But let's say that let's say the magic wand, on a painting, I can get a sim that has the visual and that feels like your ear, right? And it also shakes you, so that when you get to the moon, you feel the same visual cues, motion cues, and dynamic response.
You want the simulator?
No. That's what I'm getting to. How much?
That's wonderful. Get your simulator to that point, but you're not there. You're still within reach of the coffee cup and a freeze button. You're missing a psychological effect. I'll back off from what Neil said. Yes, it would be nice to have a nice lunar crater in front of me, which may be the same one that everybody else trained for the last 4 years, so it's not going to simulate. I see my landing site. I saw my landing site when I pitched over at 7,000 feet. I knew where we were going to land. I mean, we saw the craters. We had them named. We knew that. But the psychological effect you get is of having it all hang out at that moment, at that time, where you have to perform. And that's what I said earlier. It doesn't have to replicate the surface. It doesn't have to replicate the control system. But it puts you in an environment which is as close to hanging it out where it really counts as you can possibly be. And I tell you what, I don't think you can substitute any kind of fidelity in the simulator for that. Nothing. Moving base, noise, visual, add it all together. You're still not, you still just don't have it out there where this is it, fella. And I'd rather find out, quote, about me at Ellington than for the first time landing on the moon.
I didn't want to fall back into that spin. What I was trying to get to was, for the in-flight vehicle, the in-flight trainer, that's the assumption, free-flight trainer, okay. How important in its development is it to make sure that its visual cues are going to look like exactly what you see when you get to the moon. How important is, for example, to demonstrate the plume and the loss of visibility that's going to come in that last 120 feet? How important is it to have something on the field of view that looks like a crater versus going to the runway? Okay, because I think that is going to drive some of the complexity issues.
Why don't you use that to augment but not to replace?
Yes.
Yeah.
We just saw some technology.
Yeah.
Some of my team saw a demonstration by Mr. Fox. I don't know his first name. Jeff. And there was some promise there, I think, in what they saw. If you guys want to comment on that briefly. It's on the top.
You could simulate that into a free flight trainer.
Augmented, could you have a kind of pass through?
You go out to Flagstaff and fly this thing if you want to absorb the cost that it's going to take to support it out there.
Or better than what that is, you said your landing was much like going through the Grand Canyon down to the bottom of the canyon there.
But I mean, your answer to your question is yes, it would be nice. But should it drive the design of this?
But you didn't do it on Apollo. You landed on the runway.
I don't think you.
But you did your redesignations easily off the Ellington runway.
Well, I
You
knew
got
you
used to
could
it.
designate it to a spot, whether it looked like a crater or a piece of concrete. I could care less.
You could complicate. You could complicate the landing task in a free flyer without endangering the vehicle or the crew. If you want to, if you want to use it for scoring, things like that, you can do it with paint or with non-dangerous objects. But I think these guys are telling you that that's not the critical aspect of a free flyer. That's a simulator. The better, the higher the fidelity of the simulator, the better. No question about that. But you can't reset it. You can't reset a free flyer. You can reset a simulator. That's basic.
Okay.
The other thing you said is, Clint and I talked about this. Money isn't the reason we should be talking about this right now. We should talk about what's the right thing to do, what kind of things we need, and then the budget has to support.
Totally agree, but what I'm trying to do is get the requirements to the must-have, to the importance. This summary was fantastic. I mean, this, trying to get the, what do you guys really think is
You
needed?
send me back, that's all I need.
Apollo 11's running short on fuel is widely known. It's been widely discussed by the press and others, and even in mission control here, people were biting their nails as to whether again, I've been flying the machines at Ellington. We took off with 9 minutes of jet fuel and someplace between 90 and 100 seconds of rocket fuel. So we were always landing with 20 or 15 or 20 or 25 or 30 seconds. We had to. And so it wasn't very much of a concern to me in Apollo 11 because it was just like what I was used to. And if I made a mistake, it would be a bad one. So I think that was, Dave Scott thinks this is one of the more important aspects and one that I haven't really thought much about. But he does think that that's an important skill, let's say, important experience to make yourself have the mindset to be comfortable in a short fuel situation. So
Neil says it exactly the way I feel. You know, it's to me, it's at one step closer to the real world. You're out there at 400 or 500 feet. You got 5 minutes of fuel, 15, whatever the hell it is. It's only you and your maker. Okay? You're running a problem in the lunar land, in the LMS, in the simulator. You have a problem. You go topsy-turvy. You land into a crater. Push the freeze button. Let's go and have a cup of coffee and talk about it. When you're in the environment Neil's talking about, you don't have a change. You don't have a freeze button. You're going to either do it or not do it. And I want to know that I can do it and feel comfortable before I get out there 250,000 miles away and have to do it one time successfully. I think putting yourself in that environment, both a risk environment. You know, John's right. I don't want to crash an LLTV, but I'd rather have the option of screwing up here and learning something and getting out of it and doing it again, because I don't have that option when I'm landing on the moon. And so there's a lot of psychological effect to the comfort level I think we gained when we were in that real world, in a lunar module, landing on the surface of the moon, that we gained because of the environment we found ourselves in the LLTV.
I mentioned also with the aspect regard to your earlier question, you do often change your landing point at some point after on your final approach. And a lot of the guys flying the practice sessions would intentionally change their landing point from the place where it was going and make themselves do that. It is, I grant you, I believe that aspect can be covered by many of these competing aspects, but it is an important part of training.
And also the sixth degree of freedom concept simulation you found yourself in. I don't find myself in a helicopter in a 6th degree of freedom mentality. I just didn't. I'm flying over there. But this one, you could drift over there. And if you intentionally put the drift in that we all did when we got familiar with what we were doing, you had to take it out. And we would pick a spot out there at Ellington to land on, and you'd force yourself to go in another direction so that you'd have to force yourself to correct. It was the environment that you found yourself in, and that you were there alone. You look over your shoulder, there was nobody there. You were going to land it, or you're going to pull the ejection seat. You're going to do one or the other. And I'd rather have that option here, because I didn't have it on the surface of the moon. Just think simple and safe. That will automatically make you cost effective, I think. Yeah. It will get the job done. And boy, there's nothing worse than saying, you should have been here when kind of thing. But it worked. It worked. And we did something right with the development of the LLTV that allowed us all to get there safely, comfortably. I was comfortable when I landed. And I attribute that to the training we had, which goes from the LMS to the helicopter to the LLTV. And as I said this morning, could we have done it without the LLTV? I'd like to think probably. John said if we flew 18, 19, and 20, would we have crashed another LLTV? I don't know. I don't think so, quite frankly. I don't think so. These crashes were mechanical crashes for the most part. If we ran out of LTVs after Apollo 14, would John and I gone to the moon on 16 and 17? Probably. Would we have made it? Probably. But probably isn't good enough. If you can cover your bit, I would rather than probably, I would like to say you bet your sweet bippy we would have made it. LTV gave me that confidence. That's all I'm saying.
We have to be really careful, because if I listen to what I'm saying, and I have the project manager hat on, therefore I have to keep an eye on the money piece of the problem, right? There's a lot of objectives associated with off-nominal events that people want to use this vehicle to train to. There's commonality with the flight system. So I'm seeing a trainer that's very complex, very expensive, and so I think we really when we get as a group, we start getting down that path, let's try to recognize it and then get back on to the onto the objectives, because there's a whole, we'll get wrapped up, I think, in convincing ourselves that we want something that maybe addresses everybody's objectives rather than, we want to find out from you guys, what are the objectives?
Kathy, I think what you're hearing from these guys is not a complex vehicle, but that a vehicle that allows you to learn how the real vehicle performs. And that's different, I think,
Well,
than putting in a whole bunch of safety complexities
but
for this
how the real vehicle performs for me is also different than that psychological ability to handle off-nominal situations, right?
No, but they're not unrelated.
Well, I can see then, do you have to train for do you have to design your simulator such that you've got I don't know, stuck-on RCS thruster? Where do you go in terms of identifying the off-nominal situations that you're able to model in the training vehicle,
Yeah.
right? And how many of those put you into an unsafe situation?
You've got an even more fundamental issue to deal with the simulator, and that's, we try to stick with what LTV and the next generation SDA does, is just trying to handle the nominal event takes enough approaches, enough times in and of itself before you even inject the failure cases. I mean, you've got to get that one nailed down. And if you understand the basics of how the maneuver is going to work, what kind of sensations you're going to feel if you do a specific input, what sensation you get out of that, what reaction do you expect from the vehicle. You need to make that basically cemented into your brain how that's going to work. And then from there, the rest of the stuff, maybe the failure cases are handled in the simulator. But you need to fully ingrain what the vehicle is going to do, what it's going to feel like, what feels right. That's the kind of stuff that you get from a real in-flight simulator.
Okay, so let me just summarize so we can move on. What I heard is getting the real feel of flying the vehicle in an atmospheric training vehicle like this is important, and some ability to add in a capability to put you in a challenging situation so that you, on the stick, flying the vehicle, have to make these decisions with your bacon on the line is also important. So not necessarily every contingency scenario, but some scenario.
You're certainly going to have a space simulator.
Yeah.
It'll be very good for a lot of those kinds of things, and you shouldn't have to duplicate all those kinds of situations in whatever you use as a vehicle for.
We agree with that, and Joe Tanner made that point very clear to us, and we agree with it. His basic input was, you need to get the muscle memory down of that task. It's a skill training.
And an X-13 to train with in Apollo. I mean, we transitioned, we learned to fly, which I'm not an expert helicopter pilot, but it gave us the vertical environment, but it was far from the fidelity of our lunar landing. And of course, it was just a basic X-13 and had, no control changes, nothing. It helped, but I'm sure glad I had somewhere else to go prior to landing on the moon. I think it's important, though, that you explore all these possibilities. This last presentation came closer to me to a potential LLTV trainer, although I don't understand the fidelity, the dynamics of it. I got lost, to be honest with you gentlemen, in the ability to reproduce what a lunar landing might be like if I'm hung under this big sky train. I lost that. I don't know how that could give me the kind of visual concept, physiological, psychological concept of what I'm looking for to get ready to go to the moon.
like some general feeling about the other options that were presented today.
Before we get into that, I'm thinking, so
So-
we presented two other concepts. I think we know how you feel about the way you flew it before. We can upgrade that to, a modern architecture, hopefully safer. We presented two other options here. What are your impressions of those?
And
Maybe start with the sky crane with the pod underneath.
Well, my own reaction is that it's a very clever idea. Could provide some useful experiences, and perhaps it could be done in quite a safe and repeatable way. A lot of questions about its fidelity in terms of the actual reaction of the control inputs. I think they can certainly roll that cockpit or capsule around underneath and probably match anything you want to do with that part. But the helicopter's motions, I don't understand how well that could match. I have some suspicions that are certain things that the normal helicopter reactions would prohibit you duplicating what you would expect in the Altair.
Sure.
So, but I think it's neat, and I don't think it give you the landing experience that I would like, but I'd have to know a little bit more about it, certainly. But it's clever. I can understand the concept of a two-person crew, and it'd be sort of like this. So the guy that was doing the training didn't have to really be able to fly the machine or know its systems real well. All he had to do was do the simulation. And I think there's merit to that concept. It has two disadvantages, in my view. One is that it takes away the pucker factor and the reality part of the reality of having to do it. And the second is, as I visualize it, it would be a far more complicated and expensive vehicle. I think that would be true. It would have the advantages, I think, of allowing more efficient use of the Altair pilot's time in getting his landings in, perhaps, but I think I come down on the side of the single pilot would be my personal preference, although I think I understand both concepts.
Can you have more than one? Can you have more variable types? Can you have some of each, I suppose?
Yeah.
Program?
As Sport was saying earlier, sure, there could be a kind of build up to more high fidelity simulation. That depends on budget, I suppose, but certainly.
But I think we're going to be challenged to find the most effective continuum of experiences to meet the training requirements that we ultimately come up with. So we will, I think Gene said it well in the beginning, you develop your requirements, you can't expect one vehicle to meet all of the requirements necessary to prepare a pilot to land on the moon. So for me, I think going through these in detail is going to be interesting, because it will help us when we get to the point of deciding. People seem to think helicopter experience is right, and so how do we, is a garden variety helicopter adequate, or do you really want to get some of these capabilities that were discussed by Bob through these VSS modifications that buy you more in the continuum that is worth the investment?
Kathy, that's one thing that just makes the hair on the back of my neck stand straight up, is that thinking that this is just a helicopter type evolution is extremely, it's a much more dynamic operation. Helicopters have the luxury of long on-station time. They can hover in close to ground. A lot of their positioning they do in close than a high come down. You're also talking maneuver extremes and velocities, and also your descent rates are much different. So I get very nervous every time I hear that we're going to train the lunar landing purely on a helicopter mentality. It just
But do you
doesn't
think?
sound
Do you
right
think
to me.
no? That's not what I was saying. About. Do you
No, I know you haven't
think,
said, but I've heard that said. So if you're not saying that,
I think though. I mean, I think there is a consensus that some component of helicopter experience is
can be
important.
valuable.
Can be,
As
or
a build-up, you're saying? Kinda
yes.
like, yeah.
There is a place for it. There is use for it, but not at the exclusion of a higher fidelity.
So you're saying have a helicopter for lunar module commanders just the same as we have T-38s for shuttle commanders?
That's what we did.
You know, in that aspect, but yet you're still going to have an STA-like vehicle
Right.
to physically train for that
Right.
last ditch lane on the, you know, that might
Right.
be.
I'll make a
Well-
comment here. It's kind of a little detail, but it's kind of an important one. There was one significant difference between the lunar module and any training vehicle we used to simulate the landing. It had an auto throttle, and it could control descent rate. It could hold descent rate. Now, we couldn't do that in any of the other machines that we had, although in a plain helicopter you can come pretty close, keeping a standard descent rate. But that was a wonderful addition. It made the lunar module much easier to fly than any LLTV or helicopter. Now, so I think the point here is that whatever the concept of the Altair actually is, and I'm sure it should have rate of descent command because that was such an important characteristic to make the handling qualities of landing good. The training devices would be nice if they had that as well. We didn't have that in the LNRV. That rate of descent command was an important function.
And so we sort of, in a sense, with the LLTV, trained for a degraded mode.
That's true.
With a handheld throttle.
Acceleration command.
We had an auto throttle, but it was for the 5/6 control.
Touch on that, I don't know if it's relevant or not, but it seems like you were doing LLTV that you worked through like a mission control where you had a room. That would be something to try to divorce yourself from.
It started very small and primitive, and it grew with time, and Wayne's probably remember, maybe others should remember. By the time we'd had a few losses, then that mission control aspect had it been beefed up a good bit and was much more effective.
Yeah.
No question about that.
Yeah. I think I made a statement yesterday morning when we were talking about an early LLRV to do some DD-T&E for both the LLTV as well as the Altair, that we really, wherever the training is done, we need to really transfer the culture of flight test a lot more effectively to that training operation than what we did in Apoll, because it suffered through 2 accidents before we got it beefed up to where it needed to be.
Wasn't a significant part of the failure was a change in the weather conditions you were willing to tolerate for training versus what was done for
It's contributed to the culture, yes. We went from 15 knot limit at Edwards to 30 knots out here.
Also, I think when we talk about operations, something Wayne has harped on us about is translating that flight test mindset from someplace like Dryden to someplace like JSC here, and that control room mentality, those operations that we kind of are used to at Dryden, make sure that transfers here to JSC when we do it in your office.
As we pointed out, maybe JSC is not the best place.
Well, I was going to point that out, and that is if you could get the guys exposed initially up at the BMS, so they get a few flights in the BMS, drop down to Edwards and do your training there, and you got a lot more airspace. It's a lot safer. We can do higher altitudes if we need to.
I'll go on the record and say I endorse that idea.
The only problem is that
lots of low wind
makes Edwards less.
Yeah, lots of low wind.
Less than optimum is the altitude, high density altitude for your operation.
2,300 feet.
199 flights.
It wouldn't be. It wouldn't affect the TV performance significantly at all. Not with the new engines.
Yeah, not with the new engines.
But it increases.
Yeah, I hope
it decreases.
What's the altitude there?
23.
What were the wind limits?
So it's a little bit lower than White Sands.
We use 15 knots.
White Sands is
But
what,
they got
3,000?
pushed up to 30. The important thing wasn't
pretty good.
the thing that killed us at Ellington was they didn't monitor the wind shear above. I know in some of the very low control power research flights, we were trying to establish how low could you go on control power and still control it. And I can remember getting a deep sea fishing line thing and tying little balloons every 50 feet on it and launching the thing and watching where the shear was. Because we couldn't really tell with a helicopter that low of a shear we were looking for to make a safe flight in for the research flights.
Sounds like it's not a great vehicle for small shear.
Well, no, in the research one, where you're really trying to determine how low you can go, because we were feeding that data into Grumman, because they had to know how low you can go. But then you build some margins on top of that.
We better move through the
Well, but compare this against, a flying like a modern version of the gimbal jet. We have to fund a control room for every single flight.
Well, you don't. If you do this, you might have to fund the same number of people that you do also. So it's not to say you're not going to be monitored or it's going to all be monitored in the cockpit. In fact, what I was trying to get at with the control room concept is that you want to divorce yourself from as much of that as possible. The bare minimum to get by to safely operate, you don't need to have somebody running your flight.
But in this case, the pilot that normally flies this airplane has everything they normally have, so there's really no increase in risk to flying this vehicle. But an LLTV, now you got somebody who's training. They may not have all the displays they need to know the engine's not performing properly today or whatever. I think we've seen, as Wayne was talking earlier, they did go up in there. When we reduced the amount of oversight and the amount, made it more of a operational trainer versus a research vehicle, that's when we started having accidents.
We think we had about the right amount in flight test out at Edwards on the RV. We undershot at Ellington, and then we overshot on the reaction. And there is, if you do it right, you can come out with I think a fairly modest CRM support for any LLT.
Add in the hazardous chemicals for the RCS, you've got an operational overhead there too. I think
there's ways around that. I think you're trying to make it fit the pattern you did before, and there may be a better way of doing it now. Without that would be I'm just saying, don't kid yourself when you think safety pilots aren't free.
No, I'm not saying it.
No,
I'm saying one person compared to potentially dozens for
it's the back support. Shooting to minimize the amount of people necessary, I think, is definitely a desire.